this is the subtopic 3.4 salt hydrolysis. Okay, salt is the substance produced normally from acid, from the reaction of acid and bases. Okay, and then we have the salt. So salt will undergo hydrolysis. Okay, in order to know the characteristic of the salt, whether it is acidic, basic, or neutral salt. Okay, so hydro stand for water, lysis means the breaking of the bond. Okay, pemotongan bond. So salt hydrolysis. Okay, so the breaking of the solid of the salt. Okay, in order to know the characteristic of the salt. So this is the process. It is known as salt hydrolysis. Okay, all right. So we have 4 types of salts. Okay, it depends on the acid-base properties. So we have a neutral salt, acidic salts, basic salts, acidic or basic salts. Okay, neutral salt, we can predict the characteristic of the salt based on the type of acid or base that we reacted. Okay, all right. So if it's neutral salt, we can. This is prediction. Okay, guys. Later on, we have to prove it. Okay, we have to prove it. How do we prove it? So that's why we have the salt hydrolysis later on. So this is like the early prediction, which help you to later on make sure that whether your proven value later on should be tallied with ataupun should be correlated with the prediction that you made earlier. Okay, prediction tu penting, and then you tallykan dengan final value of the pH. Is it correlate? Okay, that's these two correlate. Kalau correlate, that means normally, bukan normally. So we could say that you have a good high chances for your value to be correct. Okay, the value of the pH of the salt later, we need to calculate that one. Okay, so neutral salt is derived from strong acid versus strong base. If we reacted these two, okay, strong acid versus strong base, we will produce neutral salt. Okay, so senang nak imagine as if macam strong lawan strong. Okay, you produce a product that is neutral because dua-dua tak menang. So we have neutral salt. Okay, and then acidic salt is derived from strong acid versus weak base. When you react the strong acid and the weak base together, it will produce a salt that is acidic in characteristic. Sebab yang strong lah menang. Okay, ini logik kita fikir orang yang kuat mestilah dia menang kan. Strong acid versus weak base, so the strong will exhibit the characteristic on the salt. That means the pH, okay, in terms of the pH, you can imagine the pH of the salt. This is just prediction. Like I said, pH is equal to 7. If acidic salt, you can imagine that the pH will be less than 7. Okay, for basic salt, it is derived from weak acid versus strong base. So the strong will exhibit the characteristic of the salt. Okay, so this one, the pH will be more than 7. And we have acidic or basic salt. So this is between weak versus weak, guys. Weak versus weak. This is not the same as strong versus strong. Strong versus strong, it will produce a neutral salt. But weak versus weak, okay, it will not produce a neutral salt. Because kalau weak, in terms of weak, you have to consider the Ka and Kb. Okay, because strong lawan strong, dia memang strong. Dia tak ada Ka, Kb, tak ada. We don't consider in terms of Ka, Kb or for the strong acid and for the strong base. You don't do that for strong acid and strong base. Therefore, kita strong acid versus strong base produce neutral salt. But weak acid versus weak base, weak acid react with weak base. It may produce acidic salt and it can also produce basic salt. It depends on the value of Ka and Kb. Which one is larger? If the Kb is larger than the Ka of the acid, that means it will produce basic salt. Okay, if the Ka of the acid, of the weak acid, we are talking about weak and weak versus weak. If the Ka of the weak acid, okay, is larger than the Ka of the weak base, is larger than the Kb of weak base, that means the salt will be acidic. Okay, so it can be less than 7 or it can also be more than 7. So that is the prediction that we can have, okay, before we could start calculating for the pH of the salt. Okay, right. Okay, when a salt dissolves in water, okay, so that's why it is called salt hydrolysis. Normally the salt will be in aqueous solution, so the salt is in the water. Okay, so one or both of its ion may react with water and affect the pH of the solution. So imagine, okay, we have a salt and then this salt will dissociate in water. It will dissociate in water and produce ions, right? So one of the ion will have higher tendency to react with water. The moment it react with water, it will either produce H3O plus or OH minus. Bila dia produce H2O plus or OH minus, it will disturb the concentration of H2O plus and OH minus in water, remember? So it's either increase the H2O plus, okay, or increase the OH minus. So from there, we could determine whether it is acidic or is it basic. Okay, so these salts are said to have hydrolyzed in water. So hydrolysis is when the component ataupun the ion of the salt react with water. The component, I'm talking about component, that means they dissociate and produce ion. Okay, so one of the ion will react with water, will have higher tendency than the other ion to react with water. When these two react together, it will either produce H2O plus or OH minus. So inilah yang akan menyebabkan it is basic or acidic. Okay, alright. So salt hydrolysis is a reaction between salt and water. So either hydronium ion or hydroxide ion are split out of the water molecules. Okay, alright. So we're going to start with neutral salt first. Alright, so the reason it is called neutral salt, just now we have a prediction just now, bila dia react strong acid versus strong base, so it will produce neutral salt, that is the pH is equal to 7. Okay, alright, so neutral salt by definition is a salt that consists of the conjugate base and ion. Okay, so we are talking about conjugate now, okay guys. Conjugate base and ion of a strong acid from the strong acid and the conjugate acid of the strong base. Take for example, we have sodium chloride. Okay, so sodium come from sodium hydroxide. They come from sodium hydroxide. Chlorine on the other hand, chloride on the other hand, okay, chloride dengan hand campur jadi hide. Okay, chloride on the other hand comes from HCl, strong acid. Okay, alright, so we know that the reason it is called conjugate base and ion from strong acid, this is because HCl, when it dissolves in water, H2. Okay, alright, so dissolve in water, okay, fully dissociated, it will produce H3O plus and Cl minus, right? So this is again, this is the acid, right? So this is conjugate base. This is the acid, this is conjugate base. So that's why it is mentioned here, a salt that consists of the conjugate base. So see, this is conjugate base from the strong acid. So Cl come from HCl, right? From strong acid. And this Cl is also known as conjugate base, guys. Conjugate base of a strong acid. Okay, so that is what it meant by this statement there. Sodium hydroxide is also the same. So sodium hydroxide, okay, we produce sodium plus and OH minus ion. So sodium hydroxide is the base. So sodium plus is the conjugate acid. Okay, is the conjugate acid. So that is what I meant by this statement here, the conjugate acid of a strong base. So this is the base and it dissociated, it will produce this conjugate acid. Okay, all right. So, sodium hydroxide reacted with HCl to produce sodium chloride. So the thing about this conjugate, the conjugate from the strong base, okay, the cation ataupun the sodium plus of a strong base is a very weak conjugate acid. The nature of the ion itself is very, very weak conjugate acid. What do you mean by very weak? Very weak means, okay, it will not react with water to produce OH minus or H3O plus. That is what it meant by very weak. Okay, itu maksud dia. Same goes to Cl minus. Cl minus, even though it comes from HCl, which is a strong acid, but the conjugate base is very, very weak conjugate base. Okay, a very weak conjugate base. What does it mean by very weak conjugate base? It means that it will not react with anything, or it will not react with water to produce either H2O plus or OH minus. In this case, it will not react with H2O to produce OH minus because it's conjugate base kan? Conjugate base is base lah basically. Okay, alright, it's a base sebenarnya. Okay, so how do we prove this? How do we prove that this reaction, this salt is, the pH is equal to 7 ataupun is a neutral salt? Okay, alright, we need equation guys, we need equation. Okay, so to prove this salt is a neutral salt, you're gonna have to start from the salt dissociation first. Okay, so sodium chloride dissolved in water. You may use this. I prefer to go for this the second equation rather than the first equation. Okay, alright. So let's just start with aqueous lah. Kita tahu that solid it will dissolve in water. Okay, so I prefer this one rather than the first one. It's actually the same. It's just that this one will be much more familiar lah. Okay, lebih senang lah. Aqueous, that means it needs to be dissolved in water first. Okay, sodium chloride in aqueous, okay, it will produce sodium plus and chloride ion. Because before it undergoes hydrolysis, it need to be dissociated first, guys. Ni belum melalui hydrolysis, eh? This is only dissociation. So they dissolve in water and it will dissociate into its ion. The salt need to be dissociated into its ion. Now, okay, neither of these two ions will not be reacted with water to produce H2O plus or OH minus. So this one will not be hydrolyzed in water. That means Na plus H2O will not produce any H3O plus or OH minus. Same goes to Cl minus. Okay, if you were to write the equation, it will not produce any product. In fact, it will not react with water at all. So that is why, okay, the pH of the salt is equal to neutral pH. Because in water, we know that in pure water, we know that the concentration of H3O plus is the same as the concentration of OH minus. Okay, since these two ions will not react with water to produce H2O plus or OH minus, so it will not disturb the concentration of H2O plus or OH minus in pure water. Therefore, the pH is still the same. The pH of pure water is still remain 7. Okay, because why tadi? Because these two ions are very, very weak conjugate acid and conjugate with base. They will not react with water. Therefore, they produce neutral solution. Okay, alright. So let's move on to acidic salt. Rasanya dah ada idea sikit lah macam mana dia the form acidic salt solution. Neutral tadi dah tahu kan? So now we move on to acidic. Okay, so acidic salt is a salt that consists of the conjugate base anion from strong acid and the conjugate acid cation from weak base. Okay, let's predict. Let's do the prediction first lah. Okay, so acidic salt is the reaction between strong acid because the salt is acidic kan. So bila kita nak predict what type of acid or base reacting, okay, in order to produce this acidic salt, so we can predict that it should be from the strong. It should be between strong acid and weak base. Okay, so it will produce an acidic salt. So this is our prediction. pH should be less than 7. Okay, now is the time for you to prove. How do you finally get acidic salt? Okay, so we are going to be based on the salt. Okay, so we have to predict NH4 may come from NH3 from the weak base. Okay, NH4 come from NH3. Cl on the other hand come from HCl. Okay, all right. So this is strong acid. This is strong. This is weak base. Okay, so this is NH4 plus. Betul tak? NH4 plus Cl minus kan. So NH4 plus is the conjugate acid of NH3. Okay, because NH3 is the weak base. Bila dia react, it produce garam, it will produce NH4 plus. So NH3 becoming NH4 plus. So this is weak base, therefore this is the conjugate acid. NH4 plus is the conjugate acid. Okay? Alright. Sorry guys. Hello. You. Ada tengah kelas ni. Kelas ganti replacement. Okay, nanti I upload yang tu video tu. Alright, bye. Okay, where were we just now? Ni NH4 plus is the conjugate acid of NH3 of a weak base. On the other hand, Cl macam tadi is the conjugate base of HCl of a strong acid. Okay. Alright, so the thing about this NH4 plus, dia datang daripada weak base. But the conjugate acid, the NH3, kita tahu it is weak base. But how about the conjugate acid of this weak base? It is stronger. Okay, it is stronger. The cation of a weak base are strong and it will be hydrolyzed in water. Okay, it will be hydrolyzed in water. But this one, how about Cl minus? Again, the same reason that we have for NaCl just now. Cl minus is the conjugate base of HCl, right? It is a very weak conjugate base, This is by nature, guys, by nature. Okay, it will not react with water. It will not be hydrolyzed in water. All right. So this is like our justification in head lah. Dalam mind kita, that will be the justification of it. Okay, so how do we prove it? Okay, all right. So you have to have equation. So we're gonna start with salt dissociation. It will dissociate first. Okay, this is the step-by-step process. Dia tak boleh terus pergi sini. You kena dissociate first. Okay, dissociation is when dia produce the components of the salt, the cation and the anion. Okay, all right. So this is aqueous. Straight away use aqueous. Okay, NH4Cl aqueous dissociate into its ion. Okay, plus and minus. All right. Okay. Now we have to choose which of these two will undergoes hydrolysis. Okay, so Cl minus will not react with water to produce any of H2O plus or OH minus, but NH4 plus does react with water to produce, since this is conjugate acid, betul tak? NH4 plus is conjugate acid sebab dia datang daripada weak base, so dia conjugate acid. So since the conjugate acid, dia acid, so it will produce H2O plus lah. Okay, NH4 plus, okay, it will react. That's why you have to carry forward this ion. Okay, this is what we call hydrolysis. When the NH4 plus react with water, so this is what we call hydrolysis. Okay, up here is called salt dissociation. You have to have this one, guys, the reversible equation here. Okay, one more thing that I would like to remind all of you, for salt dissociation, it is not reversible. It is not reversible. It is the same as the strong acid and strong base. So the arrow used is only the forward arrow, the one direction arrow. It's not reversible. Okay, alright. Remember, so far kita kena guna arrow yang betul. Okay, arrow yang mempunyai satu arah saja hanya can be applicable for strong acid, strong base, and also salt. These two. Please bear in mind. Okay, for hydrolysis, you have to choose the ion that will be hydrolyzed, react with water. So this is reversible. Okay, alright. So you predict that tadi kan, it should be acidic salt, betul tak? And then it is from conjugate acid. So when these two reacted, it will produce H2+. You need to produce H2O+ lah. Okay, satu tadi, that's why kita ada prediction awal tadi. Okay, aku dah predict it should be acidic salt. So you should first write the H3O+ first. Nak tally kan, dia kata acidic, this one acidic. Okay, alright, so NH4+, in this case, dia adalah acid, betul tak? So acid will be the donor. It will donate one of its proton to H2O and producing H3O+. So H2O now becoming H3O+, because it accepts the proton, kan? So the charge will become positive 1. And then how about NH4+? Since they donate the proton, okay, it is now a lack of proton, so it will become NH3. So plus becoming 0 charge. So NH3 and H3O+. Okay, alright. So based on this equation, it is proven that the solution is an acidic solution based on this H3O+. Proven lah. So this is how you should be proving your characteristic of the salt. Okay, so rasanya kalau faham yang ini patutnya faham lah, lebih mudah sikit. Bukan lebih mudah, it's the same understanding we apply for basic salt. Okay, so basic salt, basically if you were to predict, basic salt is produced from strong base, sebab basic kan, strong base react with weak acid. Okay, alright, so by definition, basic salt is a salt that consists of the conjugate base of a weak acid and the conjugate acid of a strong base, okay, to produce the to produce this basic salt lah. Okay, alright, so CH3COO may come from weak acid. This is the weak acid. This is how it looks like. Okay, and then sodium may come from sodium hydroxide. So when these two sodium hydroxide react with H3COOH, it will produce the salt. Okay, if we were to write the acid-base reaction, this is how you should be writing it. Okay, alright. So this is another thing. Okay, if for acid-base reaction, okay, again we are going to be using this one direction punya arrow, one way arrow, the forward arrow only. Ada tiga lah so far: strong acid, strong base, salt dissociation, and also reaction between acid and base. Okay, you need to use this one direction punya arrow. So it will produce this CH3COO and A plus H2O. Okay, so see, this is the salt that will be produced from these two reaction, from these two acid and bases, these two acid and base. Okay, alright, so CH3COOH is the weak acid, therefore it will produce this ion CH3COO minus, which is the conjugate base, guys. This is weak acid, therefore this will be the conjugate base. Sodium hydroxide is also the same, so this is strong base. Okay, it will dissociate to produce sodium plus, so sodium plus is the conjugate base. Okay, all right. So CH3COO minus is the conjugate base of CH3COH, the weak acid, like I've mentioned to you just now. Okay, so the anion of a weak acid are strong and it will hydrolyze in water. Okay, all right. So weak acid is weak lah. Okay, but dia punya conjugate base is stronger. Stronger as in, what do you mean by stronger? So it has the tendency to react with water. Kalau dia very weak, it will not react with water. Okay, it will not react with water to produce H2O plus or OH minus, like sodium plus. It's very weak. Conjugate acid, okay, means it will not react with water to produce, since the conjugate acid can produce H3O plus. Okay, all right. Okay, this is just the justification, but this is how you should be proving it. Okay, so you have to have this equation, salt dissociation equals, okay, this need to be dissociated into its component, into its ion, okay, CH3COO minus and Ne plus. Okay, all right, so which of these two will undergoes hydrolysis, will react with water? This one will not be reacting with water because it is very weak. So this one will undergo hydrolysis with water. That means this one. Okay, you have to use this one and then react with water plus water, and don't forget the reversible arrow. Okay, so since you dah predict dah kan earlier, it should be basic salt. And then one more thing, CH3COO minus, you know that this is conjugate base kan. When dia dissociate in water, it will produce OH minus lah. Okay, it will produce OH minus. This is to prove that the salt is a basic salt. Okay, alright. So kalau based on Bronsted-Lowry, CH3COO minus, this is the weak. This is conjugate base just now kan. This is base lah basically. This is base. Okay, base is a proton acceptor, so it will accept proton from H2O and becoming CH3COOH, and the charge is 0. So initially the charge is -1, so when it accept proton, so it become more positive. That is why dia jadi 0 and with 1 hydrogen. OH on the other hand, H2O, initially it is 0 charge. Since it donate its proton, so dia adalah acid in this case. But dia donate one of the proton to CH3COO minus, becoming OH minus. Okay, so they become, now they lack of proton kan, so they become more negative. That's why you have OH minus there. The charge is -1. Okay, so this, you bulatkan this one, this proof that the salt is basic. Dah, that will be your answer. Okay, this is how you should be to proving your characteristic of the salt. The characteristic of the salt. Okay. This will be a sort of weak acid and weak base. Like I said just now, it depends on the Ka and the Kb of the weak acid and the weak base used. Okay, all right. So if a salt that consists of conjugate base of a weak acid definitely will produce conjugate base. Conjugate acid is produced from weak base. Okay, so both ion also will hydrolyze in water. Okay, did you guys notice benda-benda yang acidic salt and basic salt tadi? Okay, yang ionized in water come from the weak acid and the weak base. Yang strong tadi, it will not ionize in water. Okay, but this one, both of them come from weak acid and weak base. So this one come from NH3. This one come from HCN. So both of them come from weak acid and weak base. Okay, so both of them will hydrolyze in water, guys. Both of them will hydrolyze in water. Okay, so how do we determine? So ini akan produce, this one will produce H2O plus, this one will produce OH minus. Ada OH minus, ada H2O plus. So which one will determine the characteristic of the salt? Okay, that is the time. That is when we are going to refer to Ka and Kb. Okay, alright. Before that, kita tengok balik. Okay, NH4 plus. Okay, so this is the ion from the conjugate acid of a weak base. Okay, so this is the conjugate acid of weak base. NH3 is the weak base. So this will be the conjugate acid lah. And HCN, Cn come from HCN, right? Cn minus come from HCN. So HCN is the weak acid. HCN is the weak acid. Therefore, Cn minus is the conjugate base. Okay, if you were to have the, ini kan dia terus dia hydrolysis. You must have the salt dissociation. So please add in, guys. Please add in. So you need to have this part first, salt dissociation. Kita tinggal. Okay, alright. So we have NH4 and H4Cn. Okay, undergoes dissociation. This is fully dissociated. Okay, this is in aqueous state, producing NH4 plus aqueous plus Cn minus. Okay, these two are the ion coming from the salt. Okay, so tadi yang acidic dengan basic salt tu, we need to choose which of the two ions will undergo hydrolysis kan. This one pun sama. Bila kita check, oh, NH4 plus will hydrolyze in water. Same goes to Cn minus. Both of them will hydrolyze in water. See? So you kena buat dua-dua lah. So NH4 plus react with water, it will produce. So this is the conjugate acid of the weak base. Betul tak? The conjugate acid from the weak base. So it is an acid, it should be producing H2O plus. Okay, Cn minus pula is the conjugate base of the weak acid. Ada pening madam cakap conjugate pening Okay, you kena cepat lah. Cepat sekarang. Bila kita cerita weak base, dia punya partner dia apa? Kalau weak base, partner dia conjugate acid. Okay, if we have weak acid, the partner will be conjugate. We have weak acid, the partner will be conjugate base. Okay, so both of them will hydrolyze in water. So if NH4 plus hydrolyze in water, don't forget this double reversible arrow will produce NH3 and H2O plus. If Cn minus hydrolyze in water, okay, it will produce OH minus. Remember this one tadi kan conjugate base, so you patut produce OH minus. Masalah conflict. So how do we determine now? Okay, how do we determine whether it is acidic or basic? Because we have both of them, H3O plus and OH minus. Okay, alright, so this is the time, this is the part that we have to consider the Ka and the Kb value. Okay, alright, as you can see, it's not provided. This is just to let you know, okay, the process if we have this type of salt, okay, between weak acid and weak base. So we have an extension of steps lah dekat sini, okay, which we don't have for the previous salt. Kita ada extension step dekat situ, tapi we are not going to cover that one. Tapi saya ceritalah juga menunjukkan yang in order to determine which one is more dominant, we have to consider in terms of Ka and Kb. Kita kena consider for the Ka of NH4 plus and for the Kb of Cn minus. Tengok value siapa yang paling besar. So kalau let's say Ka is larger than the Kb, that means it will be acidic. If Kb value of Cn minus is larger than Ka, that means the salt will be slightly basic. Okay, so that's why it is mentioned here the pH of the solution will depend on the relative strength of the acid or base, which is the Ka and Kb. Kb. Okay, all right. So not to worry about this. This is like an info for you guys. Normally, the question would ask in terms of basic salt and acidic salt. Okay. So for this one is it would be sufficient for you to determine on the component of the salt. Okay, NH4 plus, like this one, NH4 plus is the conjugate acid of the weak base. Cn minus is the conjugate base of the weak acid. Okay. Predict whether the following solution will be acidic, basic, or neutral. Write the equation of salt dissociation and hydrolysis. Okay, all right. So how do you prove the given salt here is an acidic or basic or even neutral salt? How do you prove that? Okay, all right. So normally for this type of question, you would have to write the salt dissociation and the hydrolysis of salt. Okay, hydrolysis of salt. Okay, all right. So this is called hydrolysis of salt, and sebab this CH3COO minus come from the salt. So that's why nama dia hydrolysis of salt. Okay, so this is one of the component of the salt. So nama dia hydrolysis of salt. Jangan confuse pula sebab one of the component of the salt will hydrolyze in water and produce H2O plus or OH minus. Okay, alright. So how do you prove this? So do not answer NH4 plus is reaction NH4I is the salt produced from strong acid versus weak base. Okay, so that one is not, I mean, tak kuat lah, tak solid lah dia punya reason dia tu. Okay, you have to prove it using equations, using salt dissociation and hydrolysis. Okay, yang between strong acid dengan weak base tu dalam kepala otak you saja. That one would be your prediction, your early prediction. Okay, tapi kalau nak gunakan sebagai jawapan, it is not a solid reason. Okay, dia punya justification ni kita boleh consider sebagai weak justification. You kena provekan using equation. Okay, alright. So, prediction. Prediction is important. Dia penting sebab it help us to make sure that we are on track tau. Nanti you mengarut-ngarut dia ni acidic tapi you cakap basic. Okay, bila you ada early prediction, you make sure that you punya final answer should be tallied ataupun should be correlated with your prediction just now. Okay, alright. So prediction kita, this is between NH3 and HI. So HI is a strong acid, NH3 is a weak base. Oh, strong acid versus weak base. So it will produce apa salt, guys?
Acidic.
It will produce an acidic salt. That will be our prediction. Okay, so maksudnya pH should be less than 7. How about KNO3? What type of acid is it? What type of salt is this, guys?
Neutral.
Okay. How about others? Do you have different answer?
Neutral.
Okay. Alright. It's a neutral salt because it is the reaction is between, let's say lah, KOH plus HNO3, and then we identify these both. Oh, both of them come from strong base and strong acid. So both of them are strong. Therefore, it will produce a salt that is neutral ke neutral. Neutral bukan natural Saya nak cakap natural. Okay, jangan natural. You natural, you salah pH is equal to 7. Neutral. Dia akan ada dalam banyak-banyak tu akan ikut saya. Okay, minta bukan awak semualah Adalah yang terpilih tu. Okay. How about NaNO2, guys? Is it acidic, basic, or neutral?
Basic.
Okay, all right, so it is basic. Okay, we can predict that this salt is produced from NaOH. Nampak je Na, most likely will be NaOH lah. Okay, plus NO2 is this one. Jangan confuse we have HNO2 and then we have HNO3. This one, this is HNO3. This is strong acid, but this one is weak acid. Okay, all right, so this one will produce a salt that is basic. The pH should be more than 7. Okay, right. So now this is our prediction. So next will be your steps in confirming the characteristic of the salt. Okay, all right. So you need to have this one: salt dissociation, hydrolysis. Okay, so NH4HI producing NH4 plus and I minus. So this step is to produce the anion, the cation of the salt. Remember this one, guys. It should be one way saja, forward direction only. Okay, that means you boleh imagine tak bila you kena buat calculation if you have this forward saja. Okay, that means kalau initially we have 0.5. Later you kena calculate the pH and whatnot. First you have 0.5 molar. So at the end of the day, this one will totally be consumed and this will become 0.5 and 0.5. Okay, and later this one will be used to react with water, okay, and produce H2O+. At the end of the day, what we want is to calculate the pH, right? So we want to calculate this one. We need to have this concentration of H2O+. But as you can see, this involves a reversible reaction. So you have to go through the ice or ataupun pakai simplifying method. Okay, and because we want to determine this H2O+, and this is not strong, and this it is not completely dissociated in water. Boleh imagine dia punya calculation later on. This is just to prove. Later kita nak kena kira. Kita kata pH is less than 7. How less is less? Less than 7 boleh jadi 1, 2, 3, 4, 5, 6 kan. So we have to determine what is the value of the pH of this so-called acidic salt. Kena calculation. Semua kena calculate later. Kena calculate the pH. Okay? Alright, so this is just the step where you have to prove sahaja. And then later you kena confirmkan the pH. Okay, KNO3 just now. Okay, so it will undergo dissociation, but both of them will not dissociate in water. Okay, both of them will not hydrolyze in water. So the solution is neutral. Okay, so the pH is actually the pH of the water lah, basically. Alright, C. Okay, so salt dissociation producing the ion. So this one will not be hydrolyzed. This is the one that will hydrolyze in water. Don't forget the reversible arrow. Okay, alright. So tadi kita dah predict the basic kan, prediction just now. So it should be producing OH minus. And after all, this one come from HNO2. This is weak acid. So the conjugate will be conjugate base. Conjugate base is a base. Base will produce OH minus lah. Okay, and make sure yang ni jangan salah student mulalah nanti dia pening-pening nak buat equation dekat sini. Nak buat chemical formula for this one. Okay, ada tiba-tiba HNO2 ada minus kat situ. Dia pening lah, tu dia pening. Dia tak reti lah siapa donate, siapa accept. Okay, when dia accept proton, jadi apa? When dia donate proton, dia loss of proton, dia pening. Okay, so don't get pening lah. Okay, suggest the appropriate acid and base for the formation of the following salt. Write equation for the reaction of any ion with water. Okay, all right. So this is, we have done this. Okay, in fact, I've shown you on the prediction just now. We can predict from the salt just now. So this is the salt. Okay, we can predict what type of acid, the acid and the base used to produce this salt. Okay, all right. So same goes to sodium benzoate. So this is the salt. You kena tahu dulu ini salt. Okay, kebetulan dia dah cakap untuk salt. Okay, ada satu ketika di mana student are not able to determine whether the given substance is an acid ataupun base ataupun salt. Okay, dia tak tahu. Bagi pula yang dia tak familiar kan, chemical formula yang dia tak familiar kan. Dia lagi, ini acid ke, base ke atau salt kan? Confused. Okay, so you kena be careful. Kalau ini penggunaan K and then ClO4, okay, it is quite obvious lah. Tapi ada soalan-soalan yang student confused. Ini acid ke base? Okay, bagi pula ion. Ion pun boleh jadi salt Okay, sodium benzoate. So this is basically from sodium hydroxide. Okay, this one come from C6H5COO. Don't forget to have the H. Okay, guys, don't forget to have the H. This will be the weak lah. Okay, so basically from here you kena buat salt dissociation and also salt hydrolysis. Okay, alright. Tapi cuma soalan tanya, suggest the appropriate acid and base for the formation of the following salt. Ni kita suggest lah for B ni. This one pun kita boleh suggest KOH plus HClO4. So as you can see, both of them are strong acid and strong base. Okay, so tak ada hydrolysis lah. There will be no hydrolysis takes place. But this one we do have hydrolysis. Okay, right. So this one. Prediction the benzoate ion ni kata suruh suggest the appropriate acid and base, but this one does not include any acid and base. Kan? Kata suruh suggest tadi. Tak apalah. Dia pun lupa katnya. Alamak. Sikit lagi guys, nak cara kira, okay? Cara kira, and then we are done with this salt hydrolysis. Next, tomorrow will be another subtopic. Okay, alright. Calculation of pH of basic salt solution. Okay, by now you should get the idea already that at the end of the day you have to calculate the pH of the salt. You can calculate pH of the salt. Okay, alright. So just now, those are the steps that you need to go through in order to calculate the pH. You need to go through the salt dissociation, and then you have the salt hydrolysis, and finally you have the pH calculation. Okay, let's look at the example. What the question asked that normally asks for salt, determining of the pH of the salt. Okay, so let's start with basic salt dulu. Calculate the pH of a 0.1 molar solution of NaOCl. So you kena tahu that this is the salt. Okay, so this is a salt. Then given the Ka, because this is the acid, HOCl is the acid. Okay, and then this is obviously sodium, come from sodium hydroxide. Jangan ingat ni base pula. Tu yang masalah student tu. Dia nampak sodium OCl. Oh, sodium base kot. No. Okay, so you kena identify ini salt ke, ini base ke, or ini acid. Acid is quite obvious. So dia dah beritahu kat sini Ka of HOCl. And then you have Na here. Okay, so this is the salt. Sodium react dengan HOCl producing this salt. Okay, alright, so the Ka is given. So this is again guys, this is Ka of the acid. Kw is not a problem lah. Okay, we have memorized that one. Ka of the acid. Okay, alright. So let's just predict the pH of the characteristic of this salt first. Will it be acidic, basic, or neutral? Definitely bukan neutral lah. Kalau neutral tak payah buat kira-kira, senang sangat. So definitely soalan tak akan keluar. Unless soalan ABC ke, multiple choice question ke. Because kenapa? Sebab you tak perlu undergo calculation at all. Because pH is equal to 7, that's all. Okay, so it's either basic ataupun acidic. Normally lah soalan keluar. Tapi kalau rezeki you dapat neutral salt, nak buat macam mana kan? Okay, so kita predict dulu sebab kita nak make sure that kita on track later. Okay, sebab pH tu kena tally dengan kita punya prediction. Okay, so this is between sodium. Don't just based on this one. Okay guys, jangan nampak basic salt. I mean, it will be basic. You determine from scratch. Okay, so it is between it. This salt is produced from sodium hydroxide plus dengan HOCl. So this is strong base. This is weak acid. So kita predict that the salt will be basic salt. Okay, so you boleh imagine bila you buat equation for the hydrolysis later on for basic salt, you akan produce OH minus. Sebab nama pun basic salt, that means you will produce OH minus for the hydrolysis equation. When you produce OH minus, you need Kb tau. You perlukan Kb. But what is given to you is Ka. See? Nampak tak? Okay. What is given to you is Ka. So you need to change this Ka into Kb. Adakah itu a problem? No. Boleh je. Ka times Kb is equal to Kw kan. So we have this one given to us. What we want is Kb. So masukkan this one. This one is also given. So we can calculate for Kb. Okay. So these are the things yang you kena tahu. Prediction awal, dia guide us to make sure yang kita di jalan yang benar di situ. Okay, alright. So basic salt, you must produce OH minus. That means you will be using Kb. Okay, alright. So pH later on should be more than 7 lah. Okay, kalau somehow you calculate later pH less than 7, you salah kira, confirm, buat balik. Okay, alright. So how do we start, guys? Okay, so from the garam, it will undergo dissociation to produce this one, right? Okay, so from here, we are going to choose which of these two will undergo hydrolysis. After dissociation will be hydrolysis. This one will not hydrolyze, but this one will hydrolyze. So we will carry this one to the next step. So this is the equation OCl minus, react with water to produce HOCl and OH minus. See? Betul tak saya cakap? Sebab kita dah predict the basic tadi. So you should be producing OH minus. Okay, now is the time to have value. So bila you produce OH minus, you pakai Kb, you tak pakai Ka. Okay, alright. So now is the time to insert value, guys. Value. Okay, dia ni tunjuk Kb dulu lah. Okay, you cari Kb. This is the expression. Tapi we can simply plug in the Kw over Ka to get the Kb. Dah dapat Kb. So nanti kita nak pakai lah this Kb. Okay, alright. So, okay, so we're going to be using this equation from the hydrolysis. Okay, guys. Okay, so how do we know that this is 0.1 suddenly, kan? Jadi kita tahu ni 0.1. So because initially what we have is 0.1 molar of NaOCl, not the OCl minus. It's not given directly to us lah. But what we have ataupun what is given to us is for the salt, the concentration is 0.1. Tapi kenapa tiba-tiba OCl minus pula jadi 0.1? Okay. So this is the part dekat sini yang saya kata fully dissociated initially, kan? This one is given to us 0.10 molar. So after dissociation, this one will be totally dissociated. That means it will be 0 after dissociation. So all of them will be forming Na plus and 0.10 molar. Okay, this we are not going to use this one. Okay, tapi kita take note lah that the concentration should be the same. Sebab apa? Dia fully dissociated. Okay, alright. So once we have this one, kita carry forward je lah dekat bawah ni. Faham? Kita buatlah ice table, gerebak-gerebu, duduk. Kita nak cari this one ni. Sorry. What we want is this one. Okay, so bear in mind if you are calculating for OH minus, nanti you akan calculate for POH, then only you calculate for pH. Okay, because kita ada OH, we have to calculate for POH and then pH. Okay, all right. HOCl is equal to, yalah, this one is X, this one is X, right? This one is X. X. Okay, so next, kita masukkanlah dalam KB expression. Okay, this is by using ice table. Okay, you boleh pakai alternative method. Ada soalan nak tanya, madam boleh tak pakai alternative method? Boleh, tak masalah. Ini nak tunjuk cara guna ice table. Okay, after all, you nampak tak KB punya value -7, which is very, very small. Okay, so you find out the X. Kenapa nak find out the X? Because what we want is this one, guys. X. Okay, and then once you have the X, the concentration of X, which is equal to the concentration of OH minus. Okay, and then you have to calculate for POH. This is your POH. Calculate for pH, and this is your pH.
Madam.
Yep.
Yang pH tu madam, final answer mesti bunda ke madam?
Jangan bunda.
Jangan
bunda.
Oh.
Leave it as this. Okay, I mean, do not round off your value. Okay, saya pun tak tahu kenapa dia round off value dia kat sini. Normally for pH we would remain the 2 decimal places. Okay, mungkin dia based on ni kot. Dia based on significant figures. Okay, dia based on significant figures ni lah. 2 kan, decimal places kan. Yang paling kecil kan. So that's why dia pakai 1, 2 kat situ. Okay, tapi untuk kalau you nak bunda, it will be good for you to do this. 10.26 is rounded off to 10. At least kita tahulah dia datang daripada 10.26 ni tiba-tiba 10. Okay? Okay. Kita normally kalau kita tengok kan, you round off the value kan, kita akan check the significant figures. Betul tak budak ni buat dia ni kenapa dia round off? Oh, dia ikut significant figures pun. Kita check lah the lowest significant figures that we had for the values kan, kita check. Sepatutnya 3 significant figures. Ini kenapa dia bagi 2? There you salah. Ataupun sepatutnya 2 you bagi 3, ataupun sepatutnya 2 you bagi 1. Okay, there. Nampak tak salah? So it would be best for you to remain at least 2 decimal places, ataupun 4 tu paling banyak lah. 2 will be good for pH. Normally kita akan ada 2 decimal places kat belakang tu. Right? Faham tak? Rasanya kalau faham yang tu, kira ini. Cuba. Okay, cuba roughly lah. Okay, this is the second example. Okay, just now we have basic salt, now we have acidic salt. Okay, alright, nampak tak soalan? Calculate the pH of 0.1 molar of ammonium nitrate. So this is ammonium nitrate. Again, you have to identify dulu whether this is a salt, acid or base. Ini kebetulan dia cakap salt kat situ. You imagine you dalam exam. Ni salt ke acid ke? Nanti pening nak buat equation. Okay, nanti bila sepatutnya salt, you pergi buat dalam bentuk acid dissociation, yang you akan dapat pelik-pelik dia punya equation. Suppose you should produce H3O+. Okay, tapi you dapat pelik lah equation dia. Itu maksudnya there's something wrong. You salah determine the substance. Okay, so identify first. So this is a salt. So it is actually between NH3 plus HNO3. Okay, producing the salt. Alamak, ke bawah pula. Okay, alright, so you have to predict. Okay, so this is weak base. This is strong acid. So kita predict the salt should be acidic. That means your pH should be less than 7. That means bila you buat reaction punya hydrolysis punya equation, you should be producing what? H3O+. Bila you produce H2O+, that means you kena pakai Ka. See, what is given to us is the Kb of ammonia. We don't need this. What we want is the Ka of NH4+. plus. What is given to us is Kb of NH3. Okay, so we will have to use this Kb in order to find the Ka of NH4 plus. This is Ke. This is Kb. Okay, right. So macam biasa, you have to have the salt dissociation. Okay, so this one will not be hydrolyzed. This is the only ion that will hydrolyze in water. So you have to have this equation. Ni markah ya. Equation ni kalau tak ada hilang markah. Ni pun kalau tak ada hilang markah. Okay, alright. So this NH4 plus will react with water. Just now we predict that it should be acidic, betul tak? Alright, so you should prepare the H2O plus first. Okay, and then kalau sini H2O plus, maksudnya one of the hydrogen will be given to H2O. So this one will become NH3, the loss of its proton. And don't forget this one, guys. It should be reversible. This one should not be reversible. Okay, alright. So that means you need to have ni you kena Ka, and then you can simply you can directly calculate the pH sebab you ada H3O plus. Okay, alright. So this is the part where you have to change the Kb into Ka. So you calculate Ka. So this is the value of Ke. There you go for this one. Okay, right. So what you want is this concentration of H2O plus because you nak masuk dalam pH later. Okay, alright. So this is by using simplifying method. You can either use ice table or you can use simplifying method. If you are using simplifying method, that means you need to have this concentration. Kenapa dia macam ni? Okay, you have to have this concentration 0.1. This one you got from this 0.1 molar. Ni daripada sini sebenarnya you dapat. This is 0.1 molar. Okay, they fully dissociated kan. Initially it is 0.1 molar. This one not yet to be formed. So after dissociation, this one is equal to 0, fully dissociated. So this one it will produce 0.1 molar of the ions. Okay, alright. So this one will not be dissociated. Yang ni yang kita carry forward here. So this is 0.1. Okay, so ice lah macam biasa. Kalau tak nak pakai ice pun boleh pakai this one. Simplify, masuk je terus dapat pH. Okay, so we have you have two options. You can either use the ice table or you can also use this one. But please bear in mind, if the question asks you to use the simplifying method, please use the simplifying method. If you are using the ice method, okay, the mark will be deducted. Sorry, sebab soalan has specified the method that you should be using for that question. Okay, all right. So please try out the checkpoint. How many checkpoint that we have so far? Okay, we will discuss it later. So kita ada satu checkpoint 11 and checkpoint question 1 and question 2. Okay. Try it first on your own and we'll discuss it later. Okay, any questions so far?
Yeah, madam.
Tak ada How about others? Alah, seorang aja daripada 80 orang tu. Seorang je yang respon.
Clear, madam.
Clear, madam. Clear, madam.
Right, okay. So, that's all for today. Okay, so tomorrow we are going to proceed with the next subtopic, the acid-base titration and indicators. So since there's no question, so I'm going to end this session now. Okay, all right. So thank you everyone and Assalamualaikum.